Hello, welcome to the video on the distributor property. This is our first example set A. So let's go ahead and practice the distributor property by starting off with this fill in the blanks question here. So we want to use the distributor property to fill in the blanks. Okay, so recall the distributor property states that you could take a number that's going to be multiplied by a sum or difference and distribute it to the parts of that sum or difference. Okay, so this is going to be 4 times 6, so we put a 6 here. Okay, plus 4 times 1. Okay, so 6 and 1. All right, so here, kind of working backwards. And let's see here, can we determine by the pattern what was being distributed? Okay, it looks like the 2 was being distributed. Okay, so because if you think about it, 2 times this value here would be 5. Okay, and then we also distributed the 2 to a 7. So you might run across a problem like this on a test or a quiz, and it's just a good way to work backwards and grasp this distributive property concept. All right, so let's go ahead and apply the distributive property to all these different problems here. So if you haven't already done so, I'd like you to go ahead and pause the video and try to do these problems. If you already have done it and want to take a look at it, let's go ahead and get into it. All right, so our first problem is going to be 3 times 6, which is, you could write it this way, 3 times 6. However, if you know what the product is and you trust yourself, you could just go ahead and write 18. But let's go ahead and do this first one. We'll write it out. So that's going to be 3 times 6 plus 3 times 2. Okay, and of course 3 times 6 is 18 plus 6. So the sum there is going to be 24. And of course we can check this by seeing that 6 plus 2 is 8, and 8 times 3 is 24. So there's another verification of the distributive property. All right, let's go ahead and just keep going here. We've got negative 4 times 1. Okay, so negative 4 times a positive 1 is negative 4. Okay, now this is key, what I'm going to talk about. Oftentimes, very often, students, when you're dealing with subtraction or difference problems with the distributive property, one thing I'm going to recommend to you, okay, is that you turn these subtraction situations, you could think of them as addition situations, okay? So the equivalent problem here would be 1 minus 5 or 1 plus a negative 5. That might help you think about this, all right? That's just one alternative. So you can go 4 times 1 is negative 4, or negative 4 times negative 5. Okay, so it's going to be plus negative 4 times negative 5, which would be a positive 20. All right, well, let's take a look at this problem again, but this time let's go ahead and leave it as a minus situation. So it'd be negative 4 times 1, which would be negative 4, minus a negative 4 times a positive 5. This time we're leaving that subtraction sign alone. Okay, so negative 4 times a positive 5 is, okay, would be negative 20. Okay, so negative 4 times a positive 5 is negative 20. So here, let's give ourselves some more room. This would be negative 4 plus a negative of a negative 20, which would be negative 4 plus 20. Okay, so you have to kind of go through a couple different steps here to figure this negative stuff out. Now let's go back one more time and take a look how I suggest you can do this. Okay, you could turn the subtraction problem into an addition problem. So it'd be plus negative. All right, so negative 4 times 1, negative 4. So it's plus, okay, a negative 4 times negative 5, which is positive 20. All right, so you can see how we kind of jumped and took a couple, steps out of doing the problem by doing it the way I suggested you to do these distributive property situations. And of course, if you know in your integers, the answer is 16. All right, so this is why I stated in the lesson video, and I'm going to continue to state that the distributive property is extremely important, and it's easy to mess up. Okay, it's easy to apply, it's easy to do correctly, but it's also easy to make a mistake, especially when there's these little negative signs all around the place. It's very easy to make a mistake. Okay, let's move on. So recall from the lesson that the distributive property can be the number that you're being multiplied doesn't have to be on the left-hand side. All right, so you can apply the distributive property this way. Me personally, I don't like this. I just don't like the feel of this look. So you could rewrite the problem or think of the problem just like this. Okay, those are equivalent statements. So if you don't like the 2 to the right-hand side, just move it over to the left-hand side, and then you can go and apply the distributive property. So that would be 14 plus 6 or 20. All right. Or if you did it this way, that would be 6. 2 times 3 is 6, plus 2 times 7 is 14, which of course is 20. All right, moving on. All right, another situation that sometimes students kind of confuse. Now this negative sign right here, you don't see any numbers, but really what you have here is a negative 1. Okay, when you don't see a number, okay, there's not a 0 here, there's a 1. So really this is a negative 1 times this. So let's take a look at this. Negative x minus 1. Anytime you see this, all right, don't say, oh, well, there's nothing being multiplied. No, there's a negative 1 out here. All right. Likewise, if I just wrote x minus 1 and there's nothing there, well, there's always 1, because 1 is always a factor of any number. Okay, let me give you one last example, or 2 examples to look at. Here we have 4. Okay, I don't write 4 times 1, right? We just write 4. Okay, x, we don't go 1 times x, which is the same thing as x. Okay, it's just assume that we have this 1 out here. So when you have this negative, I want you to remember that's a negative 1. Okay, so hopefully I think I've made that clear. So now, knowing that, we can go ahead and apply the distributive property. So negative 1 times x, negative 1 times x, and negative times a positive will be negative 1x. Now you can write it this way. However, it's more appropriate to write it negative x. Okay, it's implied that there's a 1 here. Okay, we have a subtraction situation. All right, so what do you want to do? Me personally, think of that as plus negative. So we have a negative 1 times a negative 1. Positive 1. Okay, so if you don't do it the way I'm doing it, and you're comfortable doing it, which is the previous process that we looked at back here, let me go doing it this way, that's fine. Okay, kind of choose your comfort zone as long as you're getting the right answer. That's most important. Okay, let's take a look at these last 2 problems. So hopefully these are pretty easy now. 2 times y, 2y, plus 2 times 6. Okay, 2 times 6 is 12. And at this point, there's nothing more you can do. Okay, this is simplified as far as you can go. You can't add a 2y plus a 12. Okay, we're going to be talking about in later videos how to combine like terms and what that means, but just take it from me for now that this is as simple as this can go. And likewise, when you have a variable and a number, this is as simple as this particular expression can go also. Okay, once again, we have a variable, or the number, or the variable, excuse me, that we're going to be multiplying the difference here on the right-hand side. So just think of it on the left-hand side. So it's going to be x minus 10. Now when you switch the x over to the right-hand side, you don't do anything with what's inside the parentheses. Leave that the same. That's important. All right, so now we go x times x is the same as x times x. And anything, like for example, 2 times 2, you can write as a power, 2 squared. So x times x is x squared. X times x is x squared. Now we have this minus here, and we can go minus x times a positive 10. This is positive and that's positive, so you'll have 10x. All right. And remember, 10x squared minus 10x is the same thing as x squared plus a negative 10x. Right, so if you decided to rewrite the problem that way, you'd still get the same answer. X, a positive x times a negative 10 is negative 10x. All right. So get comfortable with these problems. Once you feel very comfortable with the problems here, move on to the next example set, okay? Because I want to take a look at some other cases. All right, good luck.